Now we come to the final section of this chapter and the final section of Physics 1, that is the entropy on the microscopic scale. So far we talked about the entropy in terms of thermodynamics, but as we have mentioned before that this is related to the microscopic picture of the system. So we will briefly show the example of this relation. This is very brief and very simplified model. However, it gives us some feeling of what is the entropy and how it relates to the microscopic world. In the last section, we talked about the free expansion. If we let a molecule of the gas to move freely in the cylinder, if the cylinder of the volume of the cylinder is Vm, and if the volume of each molecule is if the volume of the cylinder is V, it's not Vm, and if the volume of each molecule is Vm, so we will have that the total number of location of the molecule if we call that the W is equal to the V over Vm. It means that each molecule will occupy the volume of Vm and the total volume of the cylinder is V. So it means that if we divided the total volume of the cylinder by the volume of one molecule, it will give us the approximately the possible location of each molecule. Okay, so this is for one molecule. Okay, this is the possible value, the total number of location of each molecule for one molecule. It means that the molecule can be anywhere, can locate in any position, and the number of position is W. We may call this the microstate of one molecule. Now, if we look at the system of n molecule, the system of n molecule, each molecule can be anywhere in this W location. So the way that we can put n of molecule where each molecule can be anywhere in this W location, we can have the number of the way to put n molecule in W possible location. We call it W. This is the big W. It's not the work, but it's the way to put n molecule in W location will equal to W over N, right? Because each molecule can be anywhere at this W location. So it means that the total way to put N molecule in W location is NW. Here, this is a little approximation that we ignore the situation that two molecule is in the same position. As we have discussed before, we are talking about the ideal gas, and one of the properties of ideal gas is the density is not too high. The temperature is high, the density is quite low. So it means that the number of gas molecules is not large. So it will be very far away from each other. So it is very small possibility that two molecules will be at the same location. So we can say that each molecule can be anywhere in the volume V, and the way to put N molecule in the W location is the W over N. Okay. These but form the definition of W